Today we had a quick question on odd and even functions. And I don't know what the problem is. It says right in the book that function is even. If f of negative x equals f of x for all that, the function is odd. If f of negative x equals negative f of x for all that, doesn't that clear everything up? Of course not. It's what's written in a math book. When you write something in a math book, it has to make sense. It has to be clear to other mathematicians. It has to be pedagogically correct and be a proper definition. So let's talk about the Cliffs Notes version of trigonometry, or I think they're called Spark Notes now, aren't they? Or do we just look up our summaries online? I think that's it. That's Dr. YouTube. So this is what we want to know about. We categorize these two kinds of functions, even and odd functions, by what happens if we change the sign of the input. What if instead of f of 2, we do f of negative 2? What happens? If the answer is nothing happens, f of negative x is just f of x. If the answer is nothing happens, it's an even function. So what happens if we change the sign of the input? If f is even, then nothing. So for example, f of x equals x squared is even. F of 2 is equal to 4. And f of negative 2 is also equal to 4. We change the sign of the inputs, nothing happened. Got the same output. So that's what we call an even function. If we change the sign of the input and that changes the sign of the output, then we get an odd function. For example, x cubed is odd. F of 2 is 8. If I change the sign of the input, f of negative 2, it changed the sign of the output. Negative 2 cubed is negative 8. Change the input, output change. For an even function, we change the input. The output does not change. So that's the difference between an even and an odd function. What happens if we change the sign of the input? The reason it has come up here is that sine is an odd function and cosine is an even function. This came up now in your trig class because sine of negative x is negative sine of x. That is, sine is an odd function. Cosine of negative x is cosine x. Cosine is an even function. We don't emphasize this as much in, let's say, algebra, because in algebra, you're mostly studying polynomials. And you're like, oh, are all the exponents even? Even function. Are all the exponents odd? Odd function. If there's a mix, neither even nor odd. But sine and cosine are traditionally our first functions that we come across where they're not polynomials. And we can classify them as even. Good questions. From a graphing standpoint, or from a unit circle standpoint, let's use the unit circle standpoint, even though we're going to be graphing momentarily. If we think about an angle and the opposite of that angle, so if we make an angle, say theta, and the opposite of that angle, negative theta. And we think about the intersection of these thetas at the unit circle. Notice that cosine theta and cosine of negative theta, same place. Those are the first and the fourth quadrant. Those are going to be the same values because it's based on the x. This is bugging me. So notice that the cosine of theta and the cosine of negative theta we can see land on the same x coordinate. But the sine of theta and the sine of negative theta have opposite y coordinates. So changing the sign of our input changed the sign of our output. So we can actually see this even and oddness in the unit circle. I think it was too wordy and I probably swore. Yeah. Math books with bad words in them. I suppose you can, but I don't know if anybody's ever tried. Now, people would lose their minds. They'll be like, oh, what about the children? Well, yeah, kids are never exposed to swearing. Funny thing is, ever since we went online, I swear a lot less in class. I don't know if it's not like a conscious decision either. I just started working from home and I was swearing. I don't know if it was because I was working from home. I don't know if it was because I was secret. I knew I was not secretly. I knew I was recording myself. And subconsciously, I didn't want like all the bad words recorded, but I still record some bad words. It's just a lot fewer. I don't know. I don't know. I'm not sure what the psychology of the whole situation is. My curses per minute? I don't know. I need a cursometer. I stopped keeping a swear jar because I don't make enough money. So that's the difference between an even and an odd function. It is definitely an interesting thing. It's another way of categorizing functions, but it's not really critical for moving forward with trigonometry. If there's a problem that hinges on even versus odd functions, this is why. It's because sine is an odd function, and where there's a sign of negative x somewhere in there, and you can replace that with negative sine x. You know, or cosine is even. So if there's a cosine of negative x, I go, well, what do I do with this cosine of negative x? And it's just like, just in time. Good thing we just learned about even and odd functions. So you can see cosine of negative x in the problem, just replace it with cosine x because cosine is even. So it's like the author of the book knew that there were going to be some problems that had where you had to deal with cosine of negative x. And they're like, oh, here, take this. And then you get this quest item. And then you go, it's like, oh, this quest item, this key opens this exact lock, just the thing that I needed, right when I needed it, because, you know, video games. Any questions? How's everybody okay? Like in video games, like, oh, you come across a lever, you pull the lever. It's like, oh, yeah, obviously. I don't even know why video games have levers for you to open stuff, because you know you're just gonna go over there and open it anyway. It's a lever. Any questions? Comments? Remarks?